In part 1 of the Effects of a Nuclear Bomb series, we took a road trip to Chicago to see how a 20 kiloton weapon would affect the city from 3 different vantage points. The effects of a nuclear weapon of this magnitude may have surprised some as to the total destruction of the heart of the city and the total lack of destruction just a few miles away. Here in part 2, we will up the ante a bit and assume that a 500 kiloton warhead is delivered by an ICBM and detonated right over the Sears Tower. Things would be somewhat different with this weapon. Something around 500 kilotons could be representative of weapons of the United States, Russia, China, Great Britain, or even France. Generally speaking, a weapon like this will be detonated in the air. Detonating a nuclear weapon in the air maximizes the amount of damage on the ground, as the ground itself doesn't absorb half the blast. While an airburst can cause more destruction with its thermal energy and blast, there is one significant difference from a ground burst. The fallout is significantly reduced. While there would be residual radiation directly under the detonation from neutron activation, very little would be sucked up into the fireball. This means fallout would be very limited. To put things in perspective, with the bomb in the first video, it would be unsafe to approach ground zero for weeks after the initial event. With an airburst, you could stand directly under ground zero immediately after the detonation with minimal radiation risk. So what would this weapon, 25 times as powerful as a terrorist nuke, do to the city of Chicago? A 500 kiloton warhead would be detonated at around 5,000 feet to maximize damage. In this case, instead of being vaporized, the Sears Tower will be simply crushed by excessive overpressure. So will the buildings around it. Even though this bomb is 25 times more powerful than the 20 kiloton weapon, and the total area destroyed is about 20 times as great, the distance from ground zero is only about 5 times greater. Instead of total destruction reaching out to 1/3 of a mile, it reaches out to around 1.5 miles. Every structure and skyscraper within this distance is destroyed. For our folks at the zoo 2.5 miles away, it's a totally different scenario than from the first video. Since the bomb will be detonating above the buildings, thermal radiation will be the very first effect they face. At this distance, thermal radiation will instantly cause third-degree burns to those with nothing between them and the bomb. Combustible materials will burst into flames only to be blown out by the blast wave that arrives 9 seconds later, with enough fury to severely damage even reinforced concrete structures. Those not lucky enough to be in one of these reinforced structures will have a high probability of being killed or severely injured by the debris carried on the 250-mile-an-hour winds that follow the blast. Initially, radiation would still not be enough to have any effect at this distance. But for those living nearby in frame homes, these houses will be completely destroyed. Broken gas mains and ruptured gas tanks would start fires, and these fires could possibly coalesce into a firestorm. There is, however, one major difference between this bomb and the first. If you are lucky enough to be in a reinforced concrete building, away from windows, and the building doesn't collapse, the radiation will probably not kill you. Because it was an airburst, most of the radioactive remnants of the bomb are now rising up into the atmosphere to be dispersed around the globe. Even so, a majority of the people at the zoo will perish. 10 miles away from ground zero at Loyola Park Beach, the scenario starts out much the same as the first. The destruction would play out, but instead of part of the skyline crumbling, most of it would disappear. The intense flash of light would last around 16 seconds, but the thermal effects and the radiation experienced at this distance would still be somewhat insignificant. When the blast wave arrives 45 seconds later, the overpressure will be enough to shatter a significant amount of glass, and it will be followed by winds of 40 miles an hour. Some poorly constructed buildings or buildings in disrepair could collapse. Injuries would be generally limited to those near glass or hit by flying debris. At 25 miles, our friends in Centennial Park will see the flash, but this time the fireball will be visible almost immediately. The intense flash of light would probably lend no illusions as to what was happening. The fireball from this 500 kiloton warhead would be expanding to about 1.25 miles wide. Even at 25 miles, the shape would be characteristic of what one might expect. The blast wave would arrive 2 minutes later with a loud crack, and the shock front would be barely perceptible, and the wind would stir to about 5 miles an hour. Damage again would be limited to freaks of atmospherics with cracked windows here and there. Even this immensely powerful bomb, a bomb that destroyed nearly the entire downtown of a major city, would have a negligible effect on a suburb 25 miles away. Far more dangerous would be the reaction of the populace and the new world that would lie ahead. Join us in the final part of the effects of a nuclear bomb series when we take a look at somewhat of a Cold War relic, a weapon of the largest deliverable size, a 20 megaton thermonuclear warhead. Are they still sitting atop an ICBM somewhere? Who knows? If you found this information to be insightful, click the like button, share this video with your friends and family, and subscribe to the Tin Hat Ranch channel. Thanks for watching.